Hello, students, dear students, very good morning. Today, before we start today's lecture, as I have told you in my previous lecture number 7, that we have already completed one chapter of chemistry, that was chapter number 1, chemical reaction and equation, that we already completed. Now, as we have completed one chapter of chemistry, now from now onwards we are targeting to start physics. As I told you, first 5 chapters of your textbook, that is chapter number 1, 2, 3, 4 and 5 are of chemistry, and then chapter number, because we are targeting to start physics today, chapter number 10, 11, 12 and 13 are of physics. Before we start your physics today, I want to give you some idea. Like in physics, chapter number, all 4 chapters are very important in physics, because all 4 chapters and its foundation and its basic needs to be made very clear, because first 2 chapters, that is chapter number 10, which we are going to start today, that is light, title of the chapter, light, reflection and refraction of light. And then chapter number 11, human eye and colorful world. Both these chapter number 10 and 11, are called chapters of optics. You must have heard the word optics means science of light. That is optics. When you go in 11-12 standard, you will learn optics in quite detail. So you have to understand your basics quite clearly in 10th standard. 2 chapters, 10 and 11 are of optics. Then we have chapter number 12 and 13. 12, that is electricity, and 13, that is magnetic effect of electric current. Both the chapters 12 and 13, electricity and magnetic effect of electric current, both are also important for you for the future standards 11th and 12th. So my dear student, whole physics chapter 10, 11, 12, 13 are most important for you. Understand, right? So you have to concentrate much on all 4 chapters. Understood? And before I start chapter number 10 today, that is in our lecture number 1, it may happen during this chapter that when I explain you anything, I may have drawn some diagram initially on the board. Why? No doubt I will give you guidance, because you are in front of me, how to draw those diagrams stepwise, step to step, and you will draw with me already. But because we want to consume less time and want to cover the topic more, that's why some diagram I will always keep drawn on the board. Okay? So today lecture number 1, chapter number 10, that is light, reflection and refraction. What we are going to study in this chapter, my dear student? We do not have to study in detail about the nature of light in this. There are so many conceptions regarding the nature of light. Understand? Regarding the particle nature of light, regarding the wave nature of light. So many concepts to understand actually what is light, but that is not we have to go in detail, but at least we have to study two phenomenons which are related to light. First phenomenon, that is called reflection of light. Second phenomenon, that is called refraction of light. And related some optical phenomenons which we are observing in daily life, like scattering of light. Because of that scattering of light only the sky appears blue, as you know. Then we will study about mirage and looming, which is also one of the explanation of total internal reflection. Then we will also study beautiful colorful rainbow which you see in the sky. That is also one sparkling phenomenon, understand, of refraction of light. You in textbook they have given some word like diffraction of light, but that is just for the knowledge, understand. We do not have to go in detail, but we are going to study various types of optical phenomenon. Today we are starting. Our first 2 to 3 lectures are dedicated only to reflection of light. And my dear student, you all know, if I ask you one question, why are you able to see the world around you? Why are you able to see every object around you? Because when light falls on any object, it throws back the incident light. Understand, means whenever light is incident on any object, specifically translucent and opaque object, not transparent. But when light, આપણે ખાલી summarize કરશું, when light falls on any object, it throws back the light, and that phenomenon we all know is known as reflection of light. Reflection takes place from any surface. Either the surface may be rough, uneven or highly polished surface. Reflection can take place from anywhere. So our today's topic, reflection, your topic number, just take it 2.1. Just now when I explained reflection, dear student, do not concentrate on this diagram. Your first target is to concentrate only on this diagram. This is important. Understand, I told you that reflection can take place from any surface. Suppose here is, you can also draw with me, here one reflecting surface PQ is drawn. Upper part is reflecting surface, so I have drawn here some dashed lines. You can see this. So this part, understand, that is painted, and this is a highly polished surface. When light falls on this polished surface, it is thrown back, means it is scattered back. Here PQ is obviously a highly polished surface which is going to reflect the light. AB is incident ray, BC is reflected ray. Question may arise in your mind, what I have drawn here, actually this is normal, because this line is meeting at a 90 degree to the reflecting surface. So you may call this normal. This is actually normal. Now try to understand. AB for us is incident ray. This is incident ray. BC for us is reflected ray. And this is normal. Suppose somewhere કઈ નામ આપી દો, R આપી દો, it's okay. So RB will be normal, AB is incident ray, BC is reflected ray. One angle forms here at the point of incidence. B is definitely the point of incidence. One angle forms between normal and incident ray, I, that is what we call angle of incidence. If in today's homework I give you define angle of incidence, so how will you define? The angle formed between incident ray and normal at the point of incidence is known as angle of incidence. Symbolically it is represented by I. R, that is angle of refraction. How will you define angle of refraction? Angle formed between normal and reflected ray, between normal and reflected ray is known as angle of reflection. Understand? You must have noted down both the definition. One I spoke of angle of incidence, one I spoke of angle of reflection. If you are asked, define normal, so any line which is, you should note it down. Any line which is perpendicular to the reflecting surface is known as normal. Now from this diagram, let us try to recall both the laws of reflection. There are two laws of reflection, and every surface, be it a highly polished plane surface, be it a curved surface, all reflecting surfaces, either in straight means planar form or in curved form, all strictly follows the laws of reflection. This is again an important question, may be asked in exam in 2 marks. How can they ask? State the laws of reflection. First law, you should note down in your book, laws of reflection. The first. When I speak the law, you should concentrate here. Each and every word needs to be understood. I am speaking from here. What is AB? Incident ray. What is BC? Reflected ray. What is RB? Normal. So the first law, incident ray, reflected ray and normal at the point of incidence all lie in the same plane. I am giving time to write it down and I am speaking again. Understood? Incident ray, reflected ray and normal at the point of incidence all lie in the same plane. एक જ plane ઉપર. Second law. Ready? Angle of incidence is always equal to the angle of reflection. Let me speak again. Angle of incidence is always equal to the angle of reflection. Two laws of reflection are there, and every surface, either plane surface or curved, that means spherical surface, follows strictly both the laws of reflection. Understood? Two laws of reflection we spoke. Now, why now your concentration has to be here? I have made a title here, image formed by plane mirror. In textbook, as you can verify if you have, they have directly given idea what type of image is formed by plane mirror. But at least I have drawn one figure here to explain you how the image is formed in plane mirror. Then we are going to discuss about how types of images are formed by spherical surfaces. But first our concentration has to be on plane mirror. And my dear student, plane mirror you do not have to find, it is in your home. Every day you are standing in front of your dressing mirror, that is plane mirror, where you see your face every day. How the image is formed in plane mirror and what are characteristic features of the image formed in plane mirror. So, you have already drawn this diagram. If you are asked in board exam, write the laws of reflection. My dear student, my guidance, you should draw a diagram and then you should write both the laws. Now your concentration has to be here. Image formed by plane mirror. Understood? You do not concentrate on the whole figure first. I will give you time to draw it step to step. Pencil, ruler, take it. Even you can draw it with pen also. It's not such a difficult diagram. Okay. Ready now? Okay. First, what you will draw from this diagram, draw plane mirror MM dash. આટલું draw કરો, इतना ही. Plane mirror MM dash. Because left side is a polished surface, so right side you have to make it opaque. એટલે અહીંયા dot dot, ऐसे dot dot करो. So plane mirror MM dash, center of the reflecting surface which we call pole, just exactly in the middle. Note down or label it as P. P is the center of the reflecting surface. કર્યું આટલું? Now draw a straight line. હું જે કહું એના ઉપર જ concentrate કરો. Draw a straight line passing from pole, say it XX dash, which we call principal axis. This much you have to first draw in diagram. MM dash plane mirror, pole and principal axis passing through this, because we want to just understand how the image is formed in plane mirror. Now what you do, just draw an object AB. AB is the object. It is kept upright. So put an arrow here, say it AB. Now we are trying to understand the formation of image. Understand by only utilizing two rays. first ray. Emerging means light falling on the object and it has reflected. The first ray parallel to principal axis. This is principal axis. First ray parallel to principal axis and meeting the reflecting surface at an angle of 90 degree. Any ray incident perpendicularly to the reflecting surface will reflect in the same direction. You can see I have drawn two arrows here. One arrow going towards the reflecting surface and this arrow showing the reflected ray. Okay? આટલું ડ્રો કર્યું. બીજે કંઈ બી અટેન્શન મત દો, જીતના મેં કહેતા ઉतना ही. ફર્સ્ટ, સેકન્ડ રે AP incident ray, and because it is falling obliquely on the pole, it will reflect in this direction. This is reflected ray. This AP is the incident ray here. This is reflected ray. Now, extend both the reflected ray behind the mirror. First ray and second ray is extended. They meet here and from here you draw the image A dash, B dash, put arrow here. So diagram is completed. Okay, this is how the image is formed in plane mirror. Now let us try to this diagram hasn't been given in your textbook, but we are just trying to understand what type of image is formed by plane mirror. Object is kept upright, image is also upright. So the first image formed by, you should note down all characteristic features of image formed by plane mirror. The first feature, image, you can visualize it from figure. First characteristic feature, that is image, note down in your book. Image formed by plane mirror is virtual, erect, and of the same size. First. Second one, image height is equal to the object height, means the height of the object and height of the image are same, they are equal. That is second feature of the image formed by plane mirror. Third one, you must have noted down both the features. Third one, just do one thing. Go in your room, stand in front, just not now, later on, stand in front of the plane mirror. Try to touch your right eye with right hand. What you will observe there? You will observe there that it looks like your left hand is touching your left eye. Means what happened? Right turn to left, and if you do the contrast, left will turn to right. That means the third, you can't call it that the image is inverted. That word is not can't be utilized here, because inverted means totally inverted image. Here image is not getting inverted. Only the right to left and left to right inversion is taking place. So you can say third feature, image formed by plane mirror is laterally inverted. Note down the word, image formed by plane mirror is laterally inverted. Fourth feature, here if you can see, I have written U and here V. What does U represent? It represents the distance between mirror and object. U is called object distance. Note down. V is representing distance between image and mirror. So V is known as image distance. My dear student, this fourth feature of the image formed by plane mirror is most important. What it suggests? Object distance, this one. Object distance is equal to the image distance. That means if an object is 10 meter away from plane mirror, image will be exactly 10 meter behind the mirror. Understand? So that is the fourth feature of the image formed by plane mirror. What I spoke? Object distance is equal to the image distance. Understood? MCQ can be asked in this. Just hear it very carefully. That suppose some name. A person is standing 5 meter away from the mirror. What is the distance between person and his or her image? So 5 plus 5 कितना होगा 10. So if a person is standing at a distance of 5 meter away from mirror, the distance between person and the image will be 5 plus 5. What is that? 10 meter. MCQ can be asked. So in textbook there is no mention of all such diagram, but at least by drawing this diagram you can understand 4 features of the image formed by plane mirror. You have noted down in your book already. The first one I speak it again. What? Image formed by plane mirror is virtual, erect and of same size. Second one you have noted down. Image height and the object height are equal. Third, image formed by plane mirror is laterally inverted. And fourth one, object distance is always equal to the image distance. So these 4 features can be asked in board exam in 2 marks. Write 4 features of image formed by plane mirror. Okay, my dear student, today I gave you an idea about topic 2.1 where we studied about reflection, laws of reflection, and we studied about the image formed by plane mirror. Why we studied this? Because initially I told you that reflection can take place from any surface. It can take place from plane surface. It can also take place from spherical or curved surface, which we are going to discuss in our topic number 2.2, where we will discuss about spherical mirrors, means curved mirrors, and how different types of images are formed by spherical mirror. Okay? Okay, so next topic we are taking in our lecture 1. As I told you that reflection can take place on any surface. It can take place on highly polished plane surface. It can also take place on spherical surface, that is curved surfaces. We have to discuss first today regarding spherical mirror, and as a general knowledge also you might be aware that there are curved mirror or spherical mirror also available. Understand? Spherical mirror, how they are made? Just let me draw one simple diagram here. Suppose I draw one hollow glass sphere. I have drawn one hollow glass sphere here. Understand, this is hollow glass sphere. From this, we are able to make spherical mirrors. Understand? From this hollow glass sphere, nothing inside, not solid. You cut any part of it. Suppose I cut this part of this mirror, understand, this part, understand, or I may cut this part of the mirror. This part also helps me to make a curved mirror. This also helps me to make a curved mirror. Understood? Any means curved mirror or spherical mirror is a part of hollow glass sphere. Understand? Just take an example. Suppose I am just drawing this part here. I have taken this curved part. Name up here. Just take an example XY. Chalo. And I say Z X Y W Z. X Y Z W. Chalo. I just want to draw and I want to magnify this part XY. Just concentrate here XY. This part we have cut from this hollow glass sphere. I want to make concave mirror from this. So what should I do? I have to make the inner surface shining and outer surface needs to be painted. How will I show the painting? Just put some dashes here. So this turns out to be concave mirror because inner shining, understand, and outer is opaque. Suppose somebody say me, okay, let me draw this. So I may draw this way, this is this way. So this is ZW. I want to convert it into a convex mirror, so the outer bulging surface has to be shining. So let me make this painted. So this is done. Two types of spherical mirror. Understand? This is concave mirror and this is convex mirror. Concave mirror inner side, convex mirror outer side. Both the mirror are ultimately a part of the hollow glass sphere. Understand? Before you study how to make or how various types of images are formed when objects are kept in front of concave or convex mirror at various positions, you need to understand some very essential terms regarding both the mirror. They have common terms. The first one, both the mirror, you should note down the term. We are defining both the terms in case of concave mirror and convex mirror. The first term you note down in your book. Just write center of curvature. Center of curvature, bracket designate by symbol C. Center of curvature. How will you define center of curvature? It is common definition for both the mirror. Either concave mirror or convex mirror. You can note down. Any spherical mirror is a part of every spherical or curved mirror is a part of imaginary hollow glass sphere, and that sphere has a center. The center of the sphere from which mirrors are made is known as center of curvature for mirror. So for convex mirror, can you guess? Center of curvature is in front, C. And from convex mirror, center of curvature is behind the mirror, center of curvature. So first definition, what is center of curvature? Every mirror, curved mirror, is a part of imaginary hollow glass sphere. Sphere has a center. The center of the glass sphere is known as center of curvature of the mirror. Same definition applies for both the mirror, concave and convex mirror. Second one, let me place here, symbolize here P. P. You should note down with me. Here also P. Dotted line में थोड़ी फेर मिला for P. P means, you should note down the second word, pole of the mirror. How will you define pole of the mirror? Symbol as you understood P. C for center of curvature, P for pole. How will you define pole? So the center point of reflecting surface, here reflecting surface is this, here reflecting surface is this. Center of reflecting surface is known as pole of the mirror. You can designate it by symbol P. Next definition, you should note down in your book, that is principal axis. What is principal axis? So I can just draw here, and this is principal axis for this mirror. Adjust kariyo. This is principal axis for this mirror. How will you define principal axis for both the mirror? Its common definition, an imaginary line passing through center of curvature and pole of the mirror. What I spoke, you should note down, an imaginary line passing through center of curvature and pole of the mirror is known as principal axis. Okay, so third definition is clear. Principal axis, you must have noted down, any imaginary line passing through center of curvature and pole of the mirror is known as principal axis. Okay, next definition, let us try to understand it. That is, you should note down the word first, principal focus. It can also be said focus. Understand? How will you define principal focus? Just with me and try to understand. There are no need to draw more rays. I am drawing just two rays. Suppose a ray, two ray I am drawing. Two rays are incident on concave mirror. Both the light rays are parallel to principal axis. So after they reflect from mirror, they both will converge at a fixed point on the mirror. Just a minute. Both the rays are parallel, and after reflection they will meet at a fixed point, and that fixed point is known as principal focus, symbolically capital F. You understood both the rays were parallel to principal axis. They were incident on concave mirror, and after reflection they both merge, means they converge at a fixed point, that is known as principal focus. How can you define in case of convex mirror? This is its reflecting surface. Any ray parallel to the principal axis of dotted line, ડ્રો કરો અંડરસ્ટેન્ડિંગ માટે, કોઈ પ્રોબ્લેમ નહીં. Two rays which are parallel to principal axis of convex mirror, after they get reflected, they will not converge like in case of concave mirror, but they seem to be diverging from each other. Suppose one ray is diverging in this direction, another ray is diverging in this direction. Now if you extend them back, they both will converge at a fixed point, that is known as principal focus or focus of convex mirror. While you define convex principal focus in both the case, you can define in a combined way also. Rays of light parallel to principal axis, after they are incident on concave mirror, they reflect and meet at a fixed point, converge at a fixed point, which is known as principal axis, which is known as principal focus. In case of convex mirror, parallel rays of light, after they are incident on convex mirror, they seem to diverge from each other, but when extended back behind the mirror, they converge at a fixed point, which is known as principal focus. So the definition of principal focus, symbolically it is capital F. Okay. Now next definition, let us target. That is focal length. What is focal length? Just mention first in your book and try to understand from here. This is PF is focal length, PF is focal length. What is focal length? It is distance between pole and principal focus of spherical mirror. In both the case it is similar. The distance between pole and focus is known as focal length. Symbolically, focal length is represented by small f. This is the symbol of focal length. Do not make any mistake. Principal focus is represented by capital F. Focal length is represented by small f. Then we want to define one another term. You should note it down. That is radius of curvature. So again come back. Both the mirrors were initially made from hollow glass sphere, and every sphere, as you know, have center as well as radius. So radius of this sphere is known as radius of curvature of both the mirror. So how will you define radius of curvature? Just try to understand the definition of radius of curvature. How will you define? Spherical mirrors are a part of or segment of hollow glass sphere. You note it down. Spherical mirrors are part of hollow glass sphere. The radius of the sphere is known as radius of curvature for spherical mirror. Symbolically, it is represented by capital R. Capital R is the symbol of radius of curvature. From here you can see ultimately the distance between pole and center of curvature is actually radius of curvature. Here also distance between pole and center of curvature is also known as radius of curvature. Okay. Now, one thing you need to understand, what is the relation between radius of curvature and focus? So you should understand and remember, radius of curvature is always double than the focal length. You should remember this. Radius of curvature is double than the focal length of the mirror. One another definition, it may be also asked, that is the definition of aperture. This word you should note down and understand it very clearly. Aperture. It in both the case, concave or convex, both spherical mirror. What is actually the meaning of aperture? You can see that both the mirror, either concave or convex mirror, both has got curved line as their surface. Here is also curved line, here also curved line. So this particular distance, if I mention in case of concave mirror, this distance xy, straightway, I am just drawing here, this distance xy is known as aperture. Understand? Ultimately it is the diameter of the spherical surface. xy, here zw is known as aperture. Understood? So what is the definition of aperture? You can understand the diameter of the spherical mirror. Understand, spherical surface is known as aperture. Okay? And my dear student, you should know that always whatever diagram and images we are going to understand and draw, you should remember one thing very clearly, that the aperture of the mirror should be quite smaller. Though here it looks bigger, but make basic clear, the aperture of the mirror should be quite smaller than the radius of curvature. We are going to discuss spherical mirror and various images formed by concave and convex mirror, but at the same time be very clear that in case of all mirror, concave or convex, the aperture is quite smaller than the radius of curvature. So we understood how many definitions regarding both the mirrors. We understood how many definitions. Let us see first. First, center of curvature. Understand? Then we discussed about another definition, that is pole of the mirror. Third, principal axis of the mirror. Fourth, principal focus of the mirror. Next, focal length of the mirror. Next, radius of curvature of the mirror, and then aperture of both the mirror. This many terms you need to understand and remember, because these terms will help you for the formation of images in case of concave mirror and convex mirror. Understand? Like my dear student, just now we studied about the image formed by plane mirror, where you have noted down one thing, that plane mirror forms only one type of image. It forms only one type of image, that is virtual, erect and of the same size. It does not form any other type of image, whether the object is nearer to the mirror or the object is away from the mirror. But the same is not the case in spherical mirror. Here, if you place the object at different distances from the mirror, you will also get various types of image. Understand? You will get various types of images. Okay? So you got some idea about concave mirror and convex mirror. You have drawn the diagram with me. Our first target is to study various image formed by concave mirror, and then we will study various types of image formed by convex mirror. But my dear student, before we understand images formed by concave mirror and convex mirror, you have to keep some point in mind that has been given in textbook also, and I just want to highlight those points which will help you for drawing various images by concave mirror and convex mirror. Let us try to understand. Which are those points which you should keep in mind at the time of drawing the ray diagram? Okay? So few points not going to be asked in exam, but at least for drawing the ray diagram, those points needs to be very clear in your mind. Just I want to mention, suppose take a first point, try to understand it. This is such hints or such points you need to remember which will help you while you draw the ray diagrams. Suppose concave mirror, ultimately you all know concave mirror. You should remember the first point. I am not designating all labels and all things P, C, F, whatever. Understand? This is concave mirror. Suppose. Try to understand one thing quite clearly. Any ray parallel to principal axis after reflection will pass through focus. You should remember this point. Clear? What I said? Any ray parallel to principal axis after reflection will pass through focus. Convex mirror follows the same rule. Suppose this is convex mirror. As you know, principal axis here. Now in case of convex mirror also, suppose F, any ray which is parallel to principal axis will after reflection direct towards the focus, point looking the same. Ultimately, તો બંનેમાં you have to remember this only. Any ray parallel to principal axis will after reflection from both the surface will pass through focus. Exactly the opposite of this is also possible. Understand? What does it say? Opposite to this. Exactly opposite to this. Here what I said, okay, any ray parallel to principal axis after reflection will pass through focus. So reverse of this you have to remember. Yes, why not? Any ray passing from focus, any ray passing from આ જ રેને reverse વિચારો. Any ray passing from focus after reflection becomes parallel. Here any ray directed towards focus after reflection becomes parallel. Exactly contradictory. Both the facts you need to remember. Understood? There are 2 points they have narrated in textbook, but ultimately with we have mixed it, and you can understand what a ray parallel to principal axis after reflection will pass through focus. A ray parallel to principal axis after reflection pass through focus. A ray passing from focus after reflection become parallel. a ray directed towards focus in case of convex mirror after reflection becomes parallel. Second point which you need to remember is this. Suppose convex mirror, concave mirror, principal axis, concave mirror. This is center of curvature. My dear student, this point is also most important. Any ray passing from center of curvature will reflect in the same direction. Means, in another word, you can say that any ray passing from center of curvature will retraces its path. Means it will reflect in the same direction. The same thing in case of convex mirror also. This is convex mirror, principal axis, this is center of curvature. So any ray, understand, any ray directed towards dotted line, center of curvature will reflect in the same direction. So this point you should remember, any ray passing from center of curvature will reflect in the same direction. This is the second point you should remember, and this will help you a lot when we draw all types of ray diagram. This is second point. Third point which you should remember, let me write here. Third point. Suppose concave mirror, suppose this is pole. Any ray incident obliquely on spherical surface will strictly follow the laws of reflection and will reflect by equal angle. This is angle of incidence and this is angle of refraction. Both are equal here. The similar case will also occur in case of convex mirror. Suppose convex mirror. Suppose this is principal axis. This is P. And what just the dotted line. What you should understand, any ray incident obliquely, this is angle of incidence, will reflect by the equal angle. This is angle of reflection. I equal to R. Understand? So these three rules you should keep in mind when we draw the ray diagrams or when we try to understand various images formed by both the types of mirror. First, ray parallel to principal axis after reflection pass through focus. Ray passing from focus or directed towards focus after reflection become parallel. Ray passing through center of curvature will reflect in the same direction. Ray incident obliquely will strictly follow the law of reflection and will reflect by equal angle. Angle of incidence and angle of reflection are equal here. Here also angle of incidence and angle of reflection are equal. So my dear student, in the next lecture when we understand various type of images formed by concave and convex mirror, keep all these rules in your mind. Okay, thank you very much from Bharat sir.